Welcome back. Moving on to the next example. Say, for example, we have the function y equals x squared plus 1. We have to find the domain and range of this given function. I have mentioned already in example number 1 that we don't always have to sketch the graph of the function for us to determine its domain and range. We can just simply look at the equation given, and from there we determine the answer. Now, this is a polynomial function. Polynomial function, to be more specific, this is a polynomial of second degree, so this is a quadratic polynomial function. I have mentioned in example number 1 that for all polynomial functions, the domain is the set of real numbers. So we already know the answer here, that the domain is the set of real numbers denoted by capital R, or in interval notation, that's from negative infinity to positive infinity. I have already said in the video on the introduction of functions that x squared here, x squared is always positive. So therefore, the smallest possible value for x squared is 0. So x squared is always greater than or equal to 0. So x squared can be 0 or any positive number. So now we know that the smallest possible value, for x squared is 0. But then the expression on the right side of the function is x squared plus 1. Okay, so if the smallest possible value for x squared is 0, but you have to add 1 on that number, so 0 plus 1 is 1. So whenever x is equal to 0, or x squared is equal to 0, then x squared plus 1 is equal to 1. So therefore, in the function y equals x squared plus 1, what is the smallest possible value for y? Remember that y is equal to x squared plus 1. So the smallest possible value for x squared is 0, and the smallest possible value for x squared plus 1 is 1. Okay, so therefore the smallest possible value for y is equal to 1. So y can be greater than or equal to 1. Okay. Recall that the range is the set of resulting values for y. So this inequality actually gives you the range of the function. What does this inequality mean? So this means that we are referring to all the values equal to 1 or greater than 1. Okay? So it means to say that y can be any positive number greater than or equal to 1. And how do we write that in interval notation? So we start from 1 up to any positive number. Now 1 is included in the solution set or in the range of the function. So we'll be using bracket to enclose the left side, and then parentheses to enclose the right side. Okay, we always make use of parentheses when we are using interval notation and writing infinity symbol like this. Okay, may it be a negative infinity or positive infinity. So this is the range of the function. Now let me show you that our answers are correct. The domain and range are correct by sketching the graph of the function. Again, this is a quadratic polynomial function, meaning to say if we sketch its graph, we'll get a parabola, particularly a parabola opening upward. Let me just recall the standard form of the equation of a parabola opening upward vertex at hk. recalling standard equation of a parabola opening upward with vertex at the point HK. This is the standard equation. It's in the form y minus k equals 4a times the quantity x minus h quantity squared. That's why whenever you see an equation where the exponent of y is 1 and the exponent of x is squared, you will always be having a parabola either opening upward or downward. What are this? This is the length of the latus rectum. If you haven't yet encountered this equation or this topic, may I suggest that you study or recall or review this topic through your previous notes or through the internet. And then the vertex is at HK, so this is the x-coordinate of the vertex, this is the y-coordinate of the vertex. Now, let us write the function y equals x squared plus 1 in this form. Alright? So in that form, y equals x squared plus 1, may just transpose positive 1 to the left, and that will give us y minus 1 equals, well, x squared is equal to x minus 0 squared, right? When we simplify x minus 0 squared, we'll always be having just x squared on the right side. Okay, so therefore the vertex of our parabola opening upward is at 0, this is h, and then this is k, 0, 1. So this is opening upward. Okay, so let's plot the vertex of our parabola at 0 on the x-axis, 0, and then 1 on the y-axis. Let's say this is 1 on the y-axis, so this is the vertex of the parabola, and then it will open upwards. Okay. Now, we don't have to be very accurate in this in the graph, so long as we have the vertex of the parabola already, and we know that it's opening upward. Well, I know that it's opening upward because both y on the left side, look at this, and x squared are positive. When you have positive y on the left side, positive x squared on the right side, you'll always be having a parabola opening upward. Now, if one of y and x squared is a negative expression, then you'll be having a parabola opening downward. Okay? So since we already know that it opens upward, we can just draw from the vertex, it opens upward like that. Okay? Now for the domain of the function, we have to look at how far does the graph go with respect to the x-axis. This is the x-axis, this is the y-axis. Okay, now this graph goes all the way upward and to the right, and then this part goes all the way upward to the left. So again, this parabola is composed of infinitely many points, alright? And these points go all the way to the right of the graph, which covers all the numbers on the positive x-axis. Now, this part of the graph goes all the way to the left as it goes up. Okay, so all the points here on the left side of the graph covers all the numbers on the left side of the y-axis, on the x-axis. Alright, so this graph means, it means that this graph covers all the numbers on the x-axis, both on the right side and on its left side. Okay, so that's why the domain is the set of real numbers. Now, as far as the range is concerned, so as you can see, you have this lowest point in the graph, which is at the vertex with coordinates 0, 1. So on the y-axis, the lowest number is 1. Okay? And since the graph on the left side and right side goes all the way up, so this graph, the parabola, will cover all the numbers on the y-axis above positive 1, above this number. Alright? So the lowest number that the graph covers on the y-axis is 1. Okay, and the highest number that the graph covers on the y-axis, we don't know that because it goes all the way up. That's why the range here is from positive 1 to positive infinity. Again, you don't always have to sketch the graph of the function to know its domain and range. If you just remember that the domain of any polynomial function is the set of real numbers, then you'll always have the correct answer. And then for the range, well, you just have to look at the equation. Now let's go to the third example. The next function is a rational function. This is a rational function. We have to find the domain and range of this rational function. Take note that for all rational functions, the domain is any rational function is the set of real numbers except, take note of this term, except, okay, except the number or numbers that will make the denominator equal to 0. Okay, let me just read that again. The domain of any rational function is the set of real numbers except the number or numbers that will make the denominator equal to 0. Okay, because what happens if we have a denominator, we'll have the denominator equal to 0, the function will be undefined. Okay, so since this is a rational function, the domain would be the set of real numbers except what number will make the denominator a 0? So the denominator is x minus 1. If we equate this to 0, then we can solve for the number that will make x minus 1 as 0 by transposing negative 1 to the other side. We'll get x equals 1. So whenever x is equal to 1, the denominator becomes 0. So what is the domain of the function now? The domain would be the set of real numbers. So real numbers denoted by capital R except 1. Okay, so in symbols, that is R, it's like a minus sign but slanting somehow. The number 1. Sorry about that. 1. What about in interval notation? How do we write the set of real numbers except 1? So in interval notation, that would be from negative infinity to 1. But 1 is not included. To denote that it is not included, instead of using brackets, we use parentheses. And then union, I hope you're familiar with the expression or the notation. Union, again 1 to positive infinity. So this means the set of real numbers except 1. So we are just excluding 1 from the set of real numbers by using parentheses in the interval notation. Now to find the range of any rational function, you do this. Solve for x in terms of y. Okay? So in our function, y equals 2x plus 1 over x minus 1, this requires a little manipulation. We have to write x in terms of y. okay, by cross multiplication, or first multiplying both sides of the equation by x minus 1. Okay, so that will remove the denominator on the right side. Now you have on the left side y times x minus 1 equals 2x plus 1. Our goal is to isolate x on one side of the equation. Simplify the equation so that we can combine like terms. So distribute y inside the parentheses. We'll have xy minus y equals 2x plus 1. And then combine these terms, 2x and xy. So we'll have to transpose 2x on the left side to combine. Okay, so that's going to be xy minus 2x transposing. And then this must go to the right to combine it with the constant. Equals 1, the same constant on the right side, and then transposing negative y to the right becomes positive y. Okay, now on the left side we have to, from here, we have to factor out x. Factoring x from both terms on the left side. Factoring x from the first term, we'll have y. And then from the second term, we'll just be left with 2 equals 1 plus y. Then divide both sides by y minus 2 to further isolate x on the left side. Cancel. We'll have x equals 1 plus y over y minus 2. What we have here is actually the inverse of the function, but then it's in terms of y. Okay, so to find the range of the function, you just have to look at the denominator again of the rational function that we have. So y minus 2. Okay, in that denominator, so in y minus 2, what number will make y minus 2 be equal to 0? Again, we just have to equate y minus 2 to 0 and then solve for y. So from there, transposing negative 2 to the left, we'll get y equals 2. Okay, again, transposing negative 2 from the left to the right. From the left to the right, we'll get the equation y equals 2. So therefore, from this equation y equals 2, that means that 2 will make this denominator a 0. So it means to say that y cannot be equal to 2, because if y is equal to 2, then this would be equal to 0, and this function will then be undefined. Okay, so the range is the set of real numbers except 2. Set of real numbers except 2. Except 2. Okay, or in interval notation, again, that's from negative infinity, in between negative infinity and 2. We don't include 2 in the set, so we use parentheses, union. Start from 2 again, but we use open parentheses to positive infinity. Go to the next video for more examples.